Welcome everyone. In this video I am going to show an interesting geometric way of calculating the tangent of 15 degrees. So our question is, what is the tangent of 15 degrees? This is our question. Now you could just use a calculator to do this, but let's say you don't have a calculator with you, and even if you were to use a calculator, you would get an approximation. The calculator might give you 10 decimals, but that won't be the exact number. And when we use our method, you will see that we will get an exact number. We will have square roots, or we will have irrational numbers, so we will have an exact number. And this is a very neat way of finding it, which you can also apply in other cases. So enough said, let's get started. I want to draw myself a triangle, and this isn't any triangle. This is a special triangle. This is a right triangle. You know, they say triangles are not always right, but they are never wrong. Well, this is one of the right guys. This is right, and I put a dot inside the box. This is my way of saying that this angle is a right angle. It is a 90 degrees angle. And I want to call this angle 30 degrees. The other one is of course going to be 60, because the interior angles of a triangle is 180 degrees. At least in the geometry that we're working with, in Euclidean geometry. Alright, we have this. And I can just assign values, right? I mean, I can't really know what the sides are. Maybe this is 2 centimeters, this 2 units, let's call it. Let's not introduce centimeters. This might be 2, this might be 1, 3, but I want to call it 1, because this is an arbitrary choice that I make. I can draw any triangle that I want, and I draw it such that the 30 degrees sees a length of 1. Alright, and that's not looking very nice. Sorry about that. So this is 1, as I was saying. And if we use now the sine and cosine values of 30 degrees and 60 degrees, we can say if we call this the h, we know that sine of 30 degrees is by definition equal to 1 over h, opposite divided by the hypotenuse. This is equal to, now you should know this in order for you to be able to find tangent of 15 degrees. So you perhaps memorize this or figure it out somehow. This is equal to 1 over 2. And as you can see, this gives us that h is equal to 2 in our drawing. So h, instead of h, I'm going to write 2. Or let's just substitute here. And if I look at the cosine of 30 degrees, it is going to be 1 over x, I want to call it. And that's not 1 over x, I'm sorry. It's going to be x over h actually, right? And this is going to give us, as again you should know this, it is going to give you the square root of 3 divided by 2. Since h is 2, we get that x is equal to the square root of 3. So we can also substitute for it here. X is equal to square root of 3. And as I said, we can't really know the dimensions of this triangle. We can stretch it. So if you want, you can add in constants here, maybe like this. You can put it as k, 2k, and square root of 3k. Okay, k is here just a number. You can add it if you want, or you can neglect it. It doesn't really matter, and I will actually neglect it. So let me draw our triangle one more time, and then we will be ready to find the tangent of 15 degrees. So we have 30 degrees, 60 degrees. This is 2, 1, and the square root of 3. Well, if I draw a line with a length of 2, and if I make it horizontal, like so, these are going to be equal. I make them equal. This is how I draw it, okay? We can't prove that they are equal, because this is an intentional choice that I make. There isn't something to prove here. I just intentionally make this length equal with the hypotenuse of our triangle, okay? This is an intentional choice, as I said. And again, I am intentionally going to just connect these two, this point and this point. Now, as you can see, we now have another triangle. And notice this is an isosceles triangle. Two sides of it are equal. We specifically chose it like that. We specifically chose it like that. So how can we figure out these two angles, which I will call alpha? How can we figure out the alphas? Well, we know that this is going to be 150 degrees because it is a supplementary angle of 30 degrees. 180 degrees minus 30 degrees gives you 150 degrees. And since the interior angles of a triangle is equal to 180 degrees, we can say that 180 degrees is equal to 150 degrees. I said degrees a lot. But anyways, plus 2 alpha. And if we solve for alpha, we get 15 degrees. This is a good sign because remember, we are looking for the tangent of alpha at the end of the day. And we got alpha finally. We did a lot of things and we haven't seen 15 degrees, but now we see 15 degrees. It is our friend alpha. And as you can notice, it is half of 30 degrees. That was why I chose it as 30 here. Now, only thing left is to find the tangent. So let me write it in green, because why not? Tangent of 15 degrees is going to be equal to, we have, well, what is the definition of tangent? It is opposite over adjacent. What is the opposite? If you look at the whole triangle, the big triangle, opposite of alpha is going to give you 1. And you might be confused. You might say, I want to use this alpha. Well, I wouldn't suggest using that because you can't really find the right triangle that it is a part of. To find trigonometric values, we often need right triangles. We need right triangle trigonometry. And since this alpha is part of a right triangle, you choose to use that one. Choosing the other one wouldn't do you any good. It wouldn't help you. So we have the opposite here, and now the adjacent side is going to be this side. So it is going to be 2 square root of 3, right? No. Why would we multiply them? Why would we multiply them? We should add them, right? We have square root of 3 here and 2 here. They are added. The sides are added together. They are connected. So we should add their length as well. So we get 2 plus the square root of 3. And this is actually the exact value of tangent 15 degrees. You could also find this value using using half angle, double angle formulas for tangent, for sine or cosine, but I think it gets a little complicated, and this is a very nice way of doing. You could use this same idea to find tangent of let's say 22.5 degrees, or tangent of, or you could find, cosine of this, cosine of that, sine of that. This is really a nice way, and we have a geometric interpretation as well. So I just wanted to share this. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.